Hello and welcome back. This is presentation 6.1, Aspects of the Normal Distribution, and this is part of a multi-part series in statistics. And we're going to review the empirical rule and statements about what it effectively says. If we consider a random variable x, such as a large population of stats marks, with a population mean of 72 and standard deviation 8, the empirical rule says that within 8 units or 1 standard deviation, 68% of the data will fall. And that corresponds to a z-score of -1 to +1. However, if we go 2 standard deviations, from z equal -2 to +2, of the mean from 56 to 88, and feel free to pause the screen at any time to verify these numbers, there's 95% chance that data will fall within 2 standard deviations. And finally, if you go 3 standard deviations, or z equal ±3, 64 to 96, the probability is 99.7%. Now we're going to look at the table of probabilities. These numbers come from a table, and in this case, the table gives us the cumulative probabilities. See the table top up here? Cumulative probabilities from the left. So the area from the left up to this black boundary line is given in this table. So for example, if we're looking for the probability z equal to 1, z greater than 1, that's the area of the white here. Well, the table gives the area to the left, that's in the blue. So if we look down the left side, z-score 1, go across to the first column, 1.0, that area is 0.8413. Now if we want the area to the right of that, we subtract that number from 1, or 15.87. So the answer here is 15.87%. Now if we want probability z greater than 2.55, again, we'll go down to 2.5, go over to the column 0.05, and come up with this number 0.9946, and the answer here, probability z is less than 2.55, is 99.46%, and the area to the right, of course, is 0.0054. Now, if we want between two values, 64 and 84, we look at the z-score. 64 corresponds to a z-score of -1. 84 corresponds to a z-score of 1.5. Going to the table, 1.5, going over, the area up to the z-score of 1.5 is 0.9932. Going to z-score of -1, we see it's 0.1587, and that's given in the screen here. So the area between is just the difference of those two numbers, 77.45%. Now we're going to look at the reverse of that. Suppose the bottom 6% were to receive a failing grade. If you look at the screen here, this means that the cumulative area to the left here, in this left tail, is 0.06. So we want to find the z-score. We go to the table, and we go into the body of the table here, because these are probabilities, and we're looking for 0.06. And we see it's down here, between two values. And watch what we do here. We go to the left, 1.5, there's a -1.5, -1.55, -1.56. Now, 0.06 is halfway between there, and so we come up with a value halfway between -1.55, 50 and 1.56, or -1.55. And there we have it here. Putting it in our z-square formula, solving for x, we have a cutoff for failing grade, for passing grade, 57.56 or 58, and that becomes the passing grade. If we go to the top 7%, it's just the reverse, except that the top 7% means the area below that is 0.93, and again, looking at the table, going to the numbers 0.93 is between two numbers here, and we do the similar thing. It's between -1.47, 1.48, and it's halfway between there. So we come up with the number 1.475. That's our z-score. And then we go to the formula, solve for x. We find x is equal to 81.8. So the cutoff for a passing grade, for an A, would be 82. And that's the end of presentation 6.1. We ask you to review once again and go to presentation 6.2.